Geometric sequences. Geometric sequences, we multiply or divide to get the next term. We don't actually really divide, we'll multiply by the reciprocal, but in general, right? So it's multiplying to get the next term. And in that case, the thing you multiply by each time to get the next term is called the common ratio. And the way you find it is by putting the second term over the first term, or in general by putting any term over the one before it. So for example, if I gave us a term that was 2, a sequence that was 2, 6, 18, 54, dot, dot, dot. If I wanted to find r, I could put 6 over the second term over the first term, 6 over 2, which will give me 3. But you could just as easily put 18 over the term before that, which is 6. Right? So that's how I find the common ratio. It's put a term over the one before it. Our general formula for a geometric sequence is this right here. Everything's the same thing as arithmetic sequence except for the r. Instead of a common difference d, it's a common ratio r. But likewise, it is u1 is the first term, r is a common ratio, and then n is the term number. N is the term we're talking about, and then un is the term number. So just like arithmetic sequence, just only difference is now we have an r, and it's a different formula. But again, it is an informal sheet. You'll be given it. You'll be provided it. So let's do an example. Consider the sequence 8, 4, 2, 1, 1/2. Show the sequence is geometric. So again, to find a geometric, we're just going to find our r. So we're going to put 4 over 8, which equals 1/2. Again, if you want to show it, let's do 2 over 4. That's also 1/2. So our common ratio is 1/2. So it does have a common ratio. It's a geometric sequence. Find the general term. So we're going to use the very basic term. un equals u1 times r to the n minus 1. So again, that is given to us in our formula sheet. It is right here. And all we have to do now is simplify just like last time for u1 and r. Right? We're going to leave n alone because that's when we want to find a certain term. That's what we're plugged into. So we just got to find those two values. And luckily for us, we have those two values. R is 1/2 and u1 is 8. So our general term is going to be 8 times 1/2 and minus 1. Now, very important, that's my general term. Remember, the way we multiply is order operations. We do exponents first, then we multiply, right? Please excuse my direct tally. Parentheses, that's nothing there. We have no parentheses. We have exponent, and then we have multiplication. So this stays like that. Do not, no, don't multiply a 1/2 and get 4 to the n minus 1. That is wrong. Because then you're multiplying before you do the power. Wrong. So this is our answer. Just leave it like that. C, hence find the 12th term. So 12th term, we're just going to substitute in 12. So u12. Remember, all that means is that we're trying to find the 12th term. And then just substitute it in for n. So 8, 1/2 over 12 minus 1. That's going to be an ugly, disgusting number. So I brought my calculator. So let's type it in. 1/2 to the, 1/2 to the 12 minus 1. And we get approximately, no, I use usually 3 sig figs, so 0, 0, 4. You might 3 sig figs, approximately. Now just to show you that this right here, if you multiply these two, it's wrong. If I did 4 to the 12 minus 1, we would get a very different answer. We get a huge number, right? So we get like almost 4 million compared to what our answer should be, which is 400 thousandths. Anyway, so that's how we do it. Next one. K minus 1, 2k, 21 minus k are consecutive terms of geometric sequence. So how do we do this? So it's very similar to when we do this for arithmetic. Since we know these are consecutive terms, then we know how to find our r. Right? If I want to find the r here, I'm just going to put this guy divided by the one before it, k minus 1. And if I want to find my r for these two, so we just found the r for these two. If I want to find my r for these two, I'm going to put the second term over the one before it. So both of these things equal r. And then, how do I solve them? Well, if they both equal r, that means we can substitute them in for each other. We get 2k over k minus 1 equals 21 minus k over 2k. And then we cross multiply. And we get 2k times 2k equals k minus 1 times 21 minus k. And then let's see. So I'm going to solve this by hand. I guess we can put in our calculator. This looks easy enough to solve by hand. 21k minus k squared minus 21 plus k. So 4k squared equals negative k squared plus 22k minus 21. Set equal to 0. I like to have my squares be positive, so I'll move everything on this side. So I'm going to add k to both sides. I'm going to get 5k squared minus 22k plus 21 equals 0. Now this actually does factor. I'll tell you right now, to save you some headache, it's 5k minus 7 and then k minus 3 equals 0. Again, you go through the whole process of factoring, but that's what you get. And you get, if you solve this, you get k equals 7/5 and 3. And again, the question is, by the way, you could have solved this with a calculator if you wanted to. Y1 here, Y2 there, figure out where they cross. So right now, it's not the prettiest crossing though. It's not the most easiest graph to look at, but it does work. Anyway, the question was find our just find k. Find k. Found my k. So that's it. Next one, a geometric sequence has u2 equal negative 6 and u5 equal 162. Find the general term. We did something like this before with the arithmetic sequence. The same idea. Since we don't have u1 or r, we're going to plug in. We're going to substitute both of these, what we do have, into the general term, which is un equals u1 times r to the n minus 1. So like for u2 minus the second term equals negative 6, we're going to substitute 2 in for n, and then we know that when we substitute in 2, it equals negative 6. So just to show you, go through all the process right here. So u1, I don't know what that is. I don't know what r is, but I do know that is 2 minus 1. Right? And then when I substitute 2 in, I get negative 6. So this is negative 6 equals u1 times r to the first. I'm going to do the same thing with this one, but I'm just going to skip that first step. So this is going to be, when I substitute 5, I plug in 5, I get 162. So 162 equals u1 times r to the 5 minus 1. So I get 162 equals u1 times r to the 4th. So here are my two equations, and once again we have two equations, two unknowns. Unlike last time though, I can't use elimination. It won't work for this. What we're going to do is use substitution. And we solve the side that has a smaller r, so over here we have r1. We're going to solve this for u1. And when we solve for u1, we're going to substitute in for the u1 over here. Then hopefully the r's will cancel out, and then we could solve. So that's how you do it when you have a geometric sequence. Elimination won't work. Substitution. Let's do it here. So let's do substitution. So now let's solve for u1. So we're going to divide both sides by r. So you get negative 6 over r equals u1. Now we'll substitute that in from our u1 over there. So I get 162. Instead of u1, I have negative 6 over r to the 4th. Now this works, even if this was r squared, r cubed, this will still work. Whatever the smaller one is, solve for u1, substitute it in for over there. And then what happens is these powers reduce. I get 162 equals negative 6 r cubed. So that's why it would still work, even if it's like r squared, r cubed. Powers still cancel out. You're still working with math. And when we have this, then we just solve it. Divide by negative 6. I get r cubed equals negative 27. I plug into the calculator off screen. And then we just cube root both this side. Now remember, you can cube root a negative. Odd roots do work. Even roots would not give it, an even root would give me a non-real result. Odd roots do work, so I get negative 3 equals r. And like before, once we have r, we have to go back and plug it in to find our u1. Now this substitution is a lot easier when you use substitution, because I'm just going to substitute this in for this guy. And use that equation. So negative 6 over negative 3 equals u1. So u1 equals 2. So I have my u1, I have my r. Now that I'm not done yet, because the question wasn't to find u1 r, it was to find the general term. So I go back to my general term. I'll be right on the side here. So un equals u1 times r to the n minus 1. I'm just going to substitute this and this in. So un equals 2 times negative 3 to the n minus 1. And again, that is my answer. Do not give me negative 6. You cannot multiply these two. This is my answer. Next one, find the first term of the sequence of 6, 6 rad 2, 12, 12 rad 2, which exceeds 1400. So I got to find the general term and want that to exceed 1400. So first step, find the general term. So right, that's un equals u1 times r to the n minus 1. Now some of this is easy. u1 is 6. What is our r? Remember, if you're not sure what the r is, from here to it tells you just multiply by rad 2. But if you're not sure, use the formula. Now this formula for R is not in your formula sheet. You just got to memorize it. It is the second term over the first term, or if you want, any term you want over the one before it, and you get rad 2. So there's my R. So I could substitute that in there. Substitute this right there. My UN is 6 times rad 2 to the n minus 1. Now again, I'm trying to solve this where this is greater than 1400. So we're going to set that up. 6 rad 2 to the n minus 1 is greater than 1400. Now, it's about solving using mathematics, like divide by 6, take the natural log both sides, but officially in this class we haven't learned it yet. So the way we solve this is y1, y2. So we're going to graph it. So there's my calculator. I'm going to go 6 times radical 2. Get out of there to the n to the x minus 1 when we have one variable, x. And over here we're going to put 1400. Now I'm going to hit graph, but I'm not going to be able to see anything because 1400 is way up there. So I'm going to change my window real quickly. So I put on to stop so I wouldn't stop thinking. So I'm going to change my window, my Y max to like maybe 2000 so I have a nice little clear window. See how that graph looks. Because again, my 1400 is like over here. So let it graph. And already it looks like you can see that this graph right here is really small. There's a 1400. I got to go way more to my right. So my window, let's make that, I don't know, 100. See how far it goes. Again, we just want to find the intersection. 100 was overkill. It looks like it's going to go up around 20 or so. And then here's the graph. Now we just got to find that intersection. So second, calculate. We shouldn't only, I gotta do a little bit more than just find an intersection. We'll talk about it right now. So right here, I have no idea where I'm at, right? But it tells you right there, you're at 45. So 45 is over here somewhere. I'm gonna go to the left. Or, pro move, press up or down, you see, and jumps to the other graph, and now I know exactly where I'm at. Just trying to get close to there. Enter, enter, enter. And I get 16.73-ish. So n. Now keep in mind, this graph is the is like 1400 is a straight line, right? I want to know when this guy's greater than this. So that's after my thing here. So n is greater than 16.7346, right? So if it was below, it'd be less than, right? I'm looking for this part's greater than. So that's what I'm asking for. So it's from here on. Now, what's the first term of the sequence? Now this is a decimal, so the first term of the sequence that exceeds 1400 will be the next one, 17th term. So there's that one. Next one, show the sequence is it geometric. Find UN, hence the 13th term as a rational number. So remember, if I just want to find it shows geometric, I'm going to find R. So I'll put negative 6 over 12, which is negative 1/2. I'm also going to do it for the next two terms to see if it matches. I get negative 1/2. So R is just negative 1/2. So it is geometric. Find UN, that's a general term. UN equals U1 times R to the n minus 1. So my UN is here is going to be U1 times R negative 1/2 to the n minus 1. Right, so that's my general term. And now we'll write the 13th term as a rational number. So let's write the 13th term. I'm substitute 13 in there. So U13 is 12 times negative 1/2. So 13 minus 1. So 12 times negative 1/2. 2 to the 12th. I don't know what 2 to the 12th is. Now I have to watch out because I want to measure it as a rational number. I can't. Rational number is a fraction. That's fine. So let's plug this into our calculator. Negative 1/2 to the 12th. So I get approximately 0.0029296. Right? Now 3 sig figs 0.003 would probably be it. If you wanted that to be a fraction, you can go press math fraction, and it'll give you a fraction, or 3 over 1024. That's the lesson.